Hi, my name is Janusz Majnert. I work for Samsung R&D Institute Poland, and I'm going to talk about the Web Runtime in Tizen. Here's the agenda. First, I'm going to introduce you to the idea of a Web Runtime. I'm going to give a brief history outline, tell you about APIs, and then a few things about browser security and how we add additional mechanisms to it. Then I'm going to briefly talk about the standardization around Web Runtimes and how I see the future of Web Runtimes and especially the Tizen Web Runtime. So you might be wondering what a Web Runtime is, what's the difference between a Web Runtime and a browser. A Web Runtime is like a virtual machine for running applications written in HTML and JavaScript. It's also an application manager. You can install, uninstall, launch applications. So you can say it's a web application execution platform. On the right-hand side, you can see an architecture diagram of Tizen application stack. On the right, you can see the native application stack. On the left, the web application stack. As you see, they are both based on the same kernel and core libraries. So it is possible for the web applications to be as powerful as native applications. A frequent question I get asked when talking about web runtimes is why do we use JavaScript and HTML? It's so slow, it's so bad, and so on, so on. So these are the reasons that I think are important. First of all, HTML and JavaScript are ready and well known. They are there, they are just available. They are also very popular now, like the whole web works on them. They are easy to experiment with, and they are open and standardized. We can influence the way it's being developed in various standardization bodies. It's also cross-platform. The applications written for one web runtime should, in theory, be launchable on all web runtimes. And last reason, one of the most important ones, is that there are already many open-sourced runtime engines available in the market, like WebKit, Chromium, and Gecko from Firefox. One of the important things about applications, web applications for web runtimes, is that they contain a web application manifest. It's a separate file that allows the author of the application to express preferences and requirements of the application. For example, application name, description, author's name, screen size, the services that the application provides. And also the application can say that it requires some features, some permissions. Like for example, to work properly, it requires access to the device camera, without which there is no sense to install it because it won't work. So the web application manifest is one of the things that enables the web application to be installed on the device. There are two basic types of web applications, packaged and hosted. The main differences are listed here. Now the package contents for packaged application is all the resources, all HTML, JavaScript files that the application needs to run properly. Whereas for the hosted applications, the bare minimum is the application manifest. Both types of applications have access to network, and well, for the packaged application, it's possible to run it in offline mode by default because all the resources are already installed and delivered in the package. Whereas for hosted applications, it is possible to run it in offline mode, but you would have to use another mechanism like app cache. Another difference is that the App Store operator can actually review and audit the code of a packaged application for security reasons, for policy reasons. The code will not change after the application is installed. The application can download additional resources, but to change the code, it has to publish an updated version. For hosted applications, where all the resources live somewhere on a server somewhere, the code can change. So they cannot be really trusted. As for access to sensitive APIs, packaged applications may have full access. If they are delivered by a trusted source, they can be trusted to not be malicious. Like I said, for hosted applications, that's not always possible. And there are also delivery mechanisms. Both types can be delivered by app stores and by sideloading. Sideloading is a term, I don't know if you know it. It's basically, you can install an app that you received via email or someone gave to you, or you copied it from a computer or other device. Hosted applications can also be installed directly from author's website, from the internet, where the author either publishes the manifest, or we can automatically create the manifest from author's website, some icon and so on. Some commercially available implementations that you might have heard of are, of course, Tizen, Firefox OS, launched recently, Chrome OS, and, for example, HP Web OS. There are many more, but they are not that popular, or yeah. Now, a brief history outline. What I would like to say with these slides is that the idea of Web Runtime is not a new one. It's already been there for a couple of years at least. So the earliest attempt that I remember happened is Google Gears in 2007. I don't know if you remember, there was like a sidebar on the desktop where all the applications were written in HTML and JavaScript. Then in year 2009, we saw many solutions, many Web Runtime solutions delivered by Opera widgets, Palm WebOS, which was later HP WebOS, which is now LG WebOS, PhoneGap, which was a like an SDK for writing iOS applications. You could write them in HTML and then convert them in some way into an iPhone application. And there were some more mature solutions with backing from telecom companies and large electronics companies like Samsung. These were Bondi, Jill, and WAC. The Tizen Web Runtime is based in most part on the WAC 2.0 specification. It takes, from this specification, it takes the runtime and security model, but adds a new set of APIs and new security mechanisms. Okay, now for the APIs. You should know that browsers provide a sort of sandbox for the code that is run inside them. And they don't usually allow the code to modify anything outside of the browser. So they don't have access to file system, to camera, to anything else you store on your computer. This makes web browsers web applications very, they can't do much. And web runtimes add a set, each web runtime adds a set of their own APIs that allow you to bridge this gap between the browser and the underlying operating system. For example, the Tizen Web Runtime exposes this set of APIs. There are generic APIs like file system, camera, Bluetooth, settings, system information, and there are more mobile-oriented APIs like messaging, telephony, contacts, calendar, secure element. The full list of APIs is available under this link. I heard that this presentation will be distributed later, so you can just Google Tizen developer guide and you'll find it. Because there are so many powerful APIs exposed by the Web Runtime, the Web Runtime has to somehow guard access to those APIs for security reasons, to prevent abuse. Now, yeah, let's talk about browser security. Browser security is based mainly on the same origin policy. It's the main security boundary for web applications. It boils down to the fact that, to the rule that applications and code coming from different origins cannot access each other. So code from my domain 1 cannot access code from my domain 2, and so on. So they cannot access each other's document object models, and they can only connect or do XHR or WebSockets or anything to their own origin. That's just a policy, so it's not a strict rule. There is no single definition. Every browser has its own set of rules, its own implementation. And there are notable exceptions from the same origin policy. For example, image tags, script tags. Having those exceptions means you can have attacks like cross-site resource forgery and the whole class of ambient authority attacks. So the browsers need to close those holes. The next big hole of browser security is JavaScript itself. It's a great language. It's very powerful. It makes various applications like Gmail possible. But it also has those features. The first row, eval, set timeout, set interval, and function allows you to execute any text downloaded from the network. Like really execute it. Then you have, you can change the window location, so you can redirect the web page to an evil site. You can do cross-site scripting, and all this leads to stealing, leaking private data, or even like, stealing money from bank accounts. Now, how does the world try to close those security holes? Basically, browser security is based on plugging the largest hole in a sinking boat. It's not a regular, like a rule. There's no mechanisms that allow you to say, yes, this is security. There are various per use case solutions, which makes it difficult to manage, and it's easy to break the security when adding new features, because you can't always predict where your feature is going to interfere with the already available security model. There are some new ways to add security, like security prompts for accessing sensitive features. But for camera, it's okay, because you can usually quite legibly explain to the user what the risk is for accessing camera. But I can think of many features where the user might not have any clue what you mean when you ask a question on a security prompt. So this is actually pushing the responsibility for security of the platform down to the end user, which is not good. There's a light in the tunnel. There are first systematic approaches to security, like CSP and CORS. It's a content security policy and cross-origin resource sharing. These are W3C specifications with a direct approach to a good approach to fixing JavaScript problems, not only JavaScript problems. And there are also changes in the upcoming versions of JavaScript that will make the language itself more secure. Okay, like I said, in Tizen Web Runtime, we add additional set of security mechanisms. Most of them are based on digital signatures of applications. Digital signatures allow you to authenticate and check the integrity of the application. Basically, even author or distributor signs all the resources in the package. You, when installing the application, are sure that the application was not changed and that the distributor, for example, Samsung App Store, guarantees that the application can be trusted. So another mechanism is the Bondi security and policy framework. It uses digital signatures to divide applications into those that are trusted and those that are not trusted. Well, basically the Bondi security framework allows you to really make a really detailed policy about which applications can do what on the platform. So you can say that, for example, applications signed by Samsung can do anything. An application signed by Mozilla can only access camera, messaging, and whatnot. And then the simplest implementation of the framework is just the simplest usage of the framework is just creating a set of trust levels. For example, 2, trusted, untrusted. So like I said, you can divide the applications into those that cannot do anything with the sensitive APIs and those that can do everything or almost everything. This model is used in Firefox OS, where you have 3 levels. You have the untrusted level, the certified level, and another very privileged level that is only used for the built-in applications written by Mozilla. Another mechanism, this time not based on digital signatures, is W3C Warp, Widget Access Request Policy. This one allows you to specify for the application which origins it's going to be connecting to via the network. So the Web Runtime can then enforce that this application can only connect to this set of IPs or URIs. Okay, now standardization. In the past, the standardization of Web Runtime technologies was based mainly on those groups. Let's start with the top. The Device APIs working group was the working group that was supposed to deliver new and exciting APIs for the web platform, not for web runtimes, but for web browsers. But it was slow. It was not delivering at the pace that the companies involved wanted. It was partly because of the slow W3C process and partly because they couldn't reach a consensus. Then there is the Web Applications Working Group, which delivered several high-quality specifications currently used by Web Runtime, like Warp, like digital signatures. These specifications were pushed forward by Opera. Yeah, and the big telecoms and the big electronics manufacturers of the world tried to push the work even faster. So they created those, first the Jill, then Bondi, and then WAC. WAC actually inherited some specifications after Jill and Bondi. And like I said, Tizen is mainly based on the WAC 2.0 specification. But these bodies ultimately failed because they hadn't, in my opinion, they had no backing from the big companies of the web, like Mozilla or Google or Facebook or, yeah. We can get this backing, but we have to do it in W3C. So now we are working in W3C in 3 groups mainly. The System Applications Working Group, which is delivering a new runtime model, a new way of launching and managing applications, running applications. and it delivers new mobile-oriented APIs. Then there's the Web Applications Working Group, which still exists. It delivers new APIs for web browsers, really good APIs. And it also works on the Web Application Manifest that I talked about earlier. So as you can see, the manifest is probably, if it succeeds, if it gains traction in the world, it's actually going to be available in regular browsers, because the Web Applications Working Group is not concentrated on web runtimes, but on web browsers. So there's also the Web Applications Security Working Group, which delivered the CSP and course specifications. Okay, now the future. This is my version. This is what I think is going to happen, so please don't put your money on it. Okay, we already observed the trend to move towards web-based environments. It's been happening for a few years now with applications like Facebook, Gmail, and so on, the Google Docs, all that stuff. It's done for several reasons: for portability, easier integration with the cloud, and faster development cycles. And another thing is that you don't actually have to build your own hardware for people to be able to use your applications. You can just release them to the web. So what I think where we will be going is that we will try to make web applications as capable and as performant as regular native applications, so that the user will not see the difference between them. And we're going to go for portability between various devices, form factors, and operating systems, so that applications written once can be run everywhere. So, in essence, I think we will see the migration of certain mechanisms and APIs from web runtimes to the regular web. Like I said, some APIs, if they are done correctly, they get popular in HTML, JavaScript world, in web technology world. They might end up in regular browsers. And the application manifest is also meant for regular browsers. So we will see a migration, a move of web browsers towards web runtimes. We have to remember that web browsers were once created to be document viewers, and the web was just a large library of online documents. It's no longer like that. It's a set of web applications. Wherever you go, whichever site you open, you're not actually getting a document, because there's a application server behind it. Facebook is not a web page, it's a service. And the application that you download is also not a document anymore. It's an application. So it's, in a way, high time to switch from a document viewer mode to an execution platform. Now for the future of Tizen Web Runtime, which again is only what's going to happen in my opinion. We are going to support the upcoming W3C system applications specifications. So we are going to implement the new runtime model and new APIs. By doing that, we will most probably achieve a level of compatibility with other runtime vendors like Firefox OS, because we are actually working with Mozilla on those specifications. And like I said before, we are going to try to get the performance and capability of web applications on the same, put them on the same level as native code. Yes, that would be it. If there are any questions, I'll happily answer them now or later, whichever way you want. Thank you. Okay, no questions. Thank you.